Same triaxial cell which I have zapped it over here. So once this chamber is pressurized with water in the first stage, so that's my first stage. If I pressurize this water, then I have two choice. First is to allow the water to escape from here. So that's my escape part. I have this gauge over here, but this time I'm using a bypass. Okay, instead of this, if I had another tube, another outlet right under the sample, I could have easily taken it out from here. But right now, I'm just using a bypass from the single opening. So let me just remove this second opening out. Okay, so somehow I'm erase the first opening. That's my first opening. So from this bypass, I can either allow the water to escape, so I have a drained condition, or I do not allow the water to escape, so I can either, my choice is either to have an undrained condition. In the second stage, I have the same thing. So once I apply this, the additional deviator load from the top, remember in second stage, I have my cell pressure which is constant. I have not changed the cell pressure, but the only thing I have done is I have applied the additional or the deviator load. So in this, under this deviator load, I can have the same thing. I can either allow the water to escape, so that cross is not there. Okay, so I can either have a drained condition, or I do not allow the water to escape, so I have an undrained condition. Okay, this leads us to 4 different kind of testing scenarios. So if I just copy this thing, so the first testing scenario would be, so in the first stage, that's my first stage, and that's my second stage. So from first stage, I have a drained, and in second stage, I have drained again. Okay, then from the first stage, I have drained, but in the second stage, I have chosen undrained. That's another different test. Or from the first stage, I have undrained, and in the second stage, I have drained. Or from the first stage, I have undrained again, and in the second stage, I have. So this leads to 4 different tests. It's kind of difficult to say drained. So I, rather than calling it drained or undrained from first stage, we would prefer to call it as either consolidated. So I replace this thing by the word consolidated. For undrained, I replace this by unconsolidated. Right? That makes it easy to understand, because now you're not. So I have C from first stage. So if I just pull this up, and D from the second stage, that's the first one. Or I have C from first stage, U from the second stage, or I have U from the first stage and D from the second stage, or I have U from the first stage and U from the second stage. Out of these 4 tests, you will find one test is in fact rubbish. It doesn't make sense. You can easily remove this UD, because in UD test, you cannot stop the water from escaping in the second stage. When you in the first stage, you tell the water to stay within the sample. So in the first stage, you, if I go back to the figure, in the first stage, what you're essentially saying is you don't allow the water to escape. So you have closed this barrier in the first stage. But in the second stage, you have opened this barrier, right? If you open this barrier from the second stage, you cannot ask the water which is from the first stage, which is still inside, the excess pore pressure which is still inside, okay, from the first stage, you cannot ask that water to stay within and then only allow the water from the second stage to escape. That is not possible. So UD test is not possible. That is why we either have a consolidated drained, a consolidated undrained, or a UU test. We have just seen the three different kind of triaxial tests. So these are the commonly used tests. But right now, what I have done is I have labeled these as the terms which you just saw on the base. Okay, the first one over here, where is this? So yeah, so that's the cell. So we just said this inlet valve is used to fill the cell with water. So water will come out. That's one. Yeah. So there are two holes over there on the underneath the sample. So one hole goes out, and I've labeled this one as pore pressure transducer. So when the water is under pressure in this, so the pore water pressure will come out and it will give a reading. Usually that's how we use. That's a PPT over there. Uh, the other two is, one is the bottom drainage. So the other hole is connected to this outlet over here for bottom drainage, and for top drainage, I have this hole which is outside the sample, but I can link it up to the sample using a tubing which goes right up to the top of the sample over here. Now, once all this is known, I would usually place my sample over the pedestal, hook it up with my membrane, seal it up with O-rings at top and bottom, and then once I have done that, I would place my cell top over it and seal this whole thing. Now, once the sample is in, I would fill the water, fill the cell with water through this opening. So I have opened this out. That's my cell, and the water gets filled up over here. And then once the water is full, I'll close this out. Okay. So once I've fill this thing, pressurize the cell, I can measure what is my pore pressure reading when this chamber is filled with pressurized water. What is the pore pressure within the sample? Now a choice. The choice is either the pore pressure which is within the sample, I drain it out, meaning I open up the bottom drainage and allow the all the excess pore pressure to escape. To again, the water goes out, I escape this. So the first part of my test is I have drained the water out. I can of course drain the water out also from the top. So I allow two-way drainage. Or when I apply cell pressure, okay, I don't open up the drainage valve. So that's unconsolidated, as we have seen. So either it's consolidated or unconsolidated. That is the stage 1 of the triaxial test. Okay. Now the stage 2 of the test is when I apply the additional load. When I apply the additional load, my pore pressure within the sample is bound to increase, because the only thing is I increase sigma 1, but keep sigma 3 and sigma 2. So two perpendicular directions, sigma 2 and sigma 3 constant. Okay, these are under my control. Sigma 2, sigma 3 and sigma 1 are under my control. Remember this always. Total stress is always under your control, your total stress. The pore water pressure is not under your control because it depends upon the response of the soil. Right, so once I apply this load on the top, I have two choices. The pore pressure which is generated within the sample, I can then open up the bottom drainage, so allow the water to escape. I can also have a choice to open up top drainage if the material is low permeable, and As the load gets incremental at every step, all the excess pore water pressure generated escapes out. So in second stage of triaxial test, when I apply the additional load, right, axial load, I can then have a choice that I allow the pore pressure to dissipate. So I open up the bottom drainage. I can also open up the top drainage for a poorly drained soil, and when I so that when I apply the next stage of the additional loading, so steps in stepwise loading, all the excess pore pressure due to the previous step has all been dissipated. Or I can keep this top drainage closed as well as the bottom drainage closed, and keep up my pore pressure opening out. So that's my pore pressure reading, it's open, so that my gauge which is attached to it, so any excess pore pressure which is generated within the sample, the gauge will tell me how much pore pressure is generated. So that gives me, again, two choice during the second stage of loading. So we have just seen in your write up that one of the choice, that is unconsolidated drained, is not a possibility. It's rubbish test. It's actually a fool's test, because in the first stage of loading, if I keep all the valves closed, my cell pressure increases, so the pore pressure is trapped within the sample. And in the second stage, if I open up my bottom drainage, when I apply the additional load, I cannot tell the water that water from the first stage you are not allowed to go in, and only the water from second stage can come out. So that is not a possibility. It's a fool's test.